As always, make sure you can hear the sound in this video. We are in Chapter 1, Study Guide in Geometry, and this video is on Lesson 1.3.1, that's Chapter 1, Section 3, Part 1, and it's on page 12 that we're going to start. So, there's actually two topics in this part 131. One of them is the midpoint formula, and the other one is the concept of having a segment bisected. So we're actually going to start with this. A segment bisector is a figure, could be a line or a plane or anything that you can draw, basically, that cuts a line segment exactly in half. So you can see right here, this line segment that starts at R and goes over to S is cut exactly in half by this line segment, VW. So there's half on this side and half on that side. So this line segment here, VW, is the segment bisector of RS. And even though it's not marked that way, it at least seems to be that these two pieces might be equal, and if that were true, then RS would also be a bisector of VW. But we can't assume anything like that. See these little markings? This little tick mark here and tick mark there? That's telling the reader that this segment from R to T is truly the same measure as this segment over here from T to S. So that we can assume is true because of the markings. But because there's no markings here and here, we can't assume that just because it looks that way. So how do you figure out how to find the distance from R to S? Well, as you can see, this distance right here is marked with a unit length of 21.7 units. And since this length over here is marked with the same tick mark, that means that that distance over there from T to S would also have to be 21.7 units. So the distance from R all the way over to S would then have to be simply the sum of the two half pieces. So 21.7 plus 21.7 gives you a full length from R to S of 43.4. Same thing down here. If we have this distance here, which is 2 1/4 units, and you see the tick mark there from A to C, that tick mark matches up with this tick mark between C and B. So that means that if this distance here is 2 1/4 units, that this distance here would also have to be 2 1/4 units because of these markings. So if I want to find the distance from A all the way over to B, I would add 2 1/4 plus 2 1/4, and I would get 4 1/2. Now, remember that sometimes when we label something, we don't always just label it with the length. Sometimes we give an algebraic name. So 3x minus 2, for example, is an expression that represents the length from B to C. I know that because it's marked right in the middle between B and C. And 2x plus 3 is an algebraic expression that's representing the length from C to D. So what do I know about these two things? Well, I know that because of this tick mark right here, the distance from B to C actually has to be the same as the distance from C to D because they have matching tick marks. One mark here and one mark there means these two lengths are the same. Now, if we want to be able to find any of these lengths, we're going to first need to figure out what x is, because x is the key to unlocking what this length actually is. Once we know what x is, we can multiply it by 3 and subtract 2, and we'll be able to figure out how long it truly is in units from B to C. which ultimately is what we've been directed to find the length from B to C. So how do we find x is the question. Well, in math we try to find things that are the same. So you can see that since this line segment here is the same as this line segment there, they have the same length and they are actually equal segments. So even though we've given it kind of a funny name, we've given it the name 3x minus 2 on one side and the name 2x plus 3 on the other side, they actually are the same thing. They're just written a little differently. They do represent the same length. So that means that those two expressions would actually have to be equal. We just simply have to find the value of x that makes them equal. So I'm going to start finding x. I'm going to subtract 2x on both sides. And I'm going to add 2 on both sides. And I find that x equals 5. Now, remember, that is not our answer. We've been directed to find the length of BC, the line segment BC, not how big 5 is, or x is. But we can use this to figure out how long a distance we have from B to C, because we can go back and we can say, okay, the original expression that represents the length of BC is 3x minus 2, but this simply needs an x value to figure out what it truly is. So we'll take 3 and we'll multiply it by our now known x value of 5. So we have 15 minus 2, which gives us a final answer of 13. Line segment BC has a length of 13. Now the next one is a little harder because when we start putting the numbers together, they actually involve fractions. So just keep in mind that the last phase here will have some fractions in it. But you will find that up until that point, the steps of the process and the simplicity of the level of difficulty of being able to solve this equation is about the same. So over here we have a tick mark between J and K, and then we have a tick mark between K and L. That means that this segment here is marked the same length as this segment here. So since this segment and this segment are the same, we can say that they are equal. So 8 minus 3x should be the same length as 2x plus 5. We just have to figure out the value of x that makes that true. So let's see. I think I'm going to subtract 2x on both sides. So that gives me 8 minus 5x equals 5. And I'm going to subtract 8 on both sides. That gives me negative 5x equals negative 3. And then if I divide both sides by negative 5, I have x equals, these two negatives will cancel, positive 3/5. Okay, well again, that really wasn't what we've been directed to find. That's simply the value of x. But it can get us there. If we want to figure out what the length from K to L is, then we can use the expression that represents the length, 2x plus 5. So I'm going to write over here, KL is 2x plus 5 in length. So since I know that x is 3/5, what I can do is I can multiply straight across here. 2 times 3 is 6. 2, you could write that as 2 over 1, and if we multiply this way, 1 times 5 is still 5. And then we need to add these two together. So in order to add a fraction with a whole number, what we need to do is take the whole number and turn it into a fraction. You can do that by writing it over 1. Then we need to establish a common denominator. We have a 5 here and a 1 here, so let's try to make them both 5s. So I can do that by multiplying this fraction, I want to turn this 1 into a 5, by 5 over 5. So the first fraction, notice I didn't do anything to it, so that remains 6/5. Over here, multiplying across the top, I get 25. And multiplying on the bottom, 1 times 5 is 5. Now I finally have a common denominator. So I will be able to now add these two fractions together. So I get 6 plus 25 is 31. And that's how many fifths I have. So you can either leave it like that, or you can write it as a mixed number. 5 goes into 31 6 times with 1 remainder. So either one of these answers is perfectly fine. You don't need both. 31 fifths or 6 1/5. Usually in higher level math, we leave it as this is called an improper fraction because the top is bigger than the bottom. We usually just leave it like that. But this is certainly not wrong. Okay. So the midpoint formula. The midpoint formula is the other topic, and I'm just going to go back a page because we need to define this first. A midpoint is pretty much what it sounds like. It is the point that divides a segment in two equal pieces. So, you know, if you've got a line segment like so, the midpoint would be smack dab in the middle. So I'm going to call it the point that exists at the exact halfway position of a line segment. Or let's just call it a segment. Okay. So the questions you'll be asked will be mainly, please calculate the midpoint. Now some of the B level and A level questions you'll have to do a little bit more fancy examples, and we'll do some of that too. But basically this is a pretty fancy diagram and it's got a lot of words to it. But what I think I'm going to do is talk about the midpoint. I'm going to jump back to the notes pages in the back of my chapter 1 book. So again, the last few pages are left blank where you can just write down your own notes, and I've been using those as we've gone through the chapter 1 videos. A midpoint. Now, midpoints are pretty logical if you think about them. For example, if I have 2 points that are oriented horizontally, so on the x-axis, this one is, let's see, something like that. Okay, so this is located at position 2. And this one is at position 9 on the x-axis. Is there a position that's exactly halfway between these two? Well, you go 1 unit on both sides, 1 unit on both sides, 1 unit on both sides. Well, it looks like the midpoint would be right here at 5.5. So we could actually calculate that by adding the two x values together, 2 plus 9, and then taking the average. When we take an average, we add certain elements together and we divide by how many elements we added. We added two numbers together, so we divide by 2. So 9 plus 2 is 11. Oops, it's a 2. And then dividing 11 by 2, I get 5.5. So that's basically how to find the midpoint horizontally. Now we can do this vertically as well. If we have a line going straight up and down, and this is, let's say, 3, 4, 5, 6, 7, 8 as correlated to the vertical y-axis. Is there a point that's exactly halfway between 3 and 8? Well, 1, 2, well, again, it would be probably around 5.5. Well, that's not the best example. Let's do a little, oh, let me make a better example. Okay, so let's start between 2 and 8. Okay, so if I want to find a point that's exactly halfway between 2 and 8, 1, 2, 3. Well, seems to me that's 5. Because there's 3 units this way and 3 units that way. Yep, that'd be 5. So rather than counting it out on a number line, what you can do is you can take the average of the endpoints. My top endpoint was 8, my bottom endpoint was 2. So if I add 8 plus 2 and take the average, since I added 2 elements together, I'm going to divide by 2 to take the average. That would be 10 divided by 2, which, yeah, that's 5. So basically averaging out the endpoints gives you an output value of exactly what the midpoint would be between the two. So that's what we're going to do over here. On page 14. So let's see. If I have 2 points, the first point is -2, 5 for my x and y values, and the second point is 4, 3 for my x and y values, and I want to find the exact midpoint between these two. Well, I have 2 x values here. This is the first x value and this is the second x value. So basically one of these x values is over here at -2 and the other x value is over here at 4, and we just have to figure out what exactly is exactly halfway between -2 and +4. Well, rather than drawing it out and counting it out, which we certainly could do, let's use our formula. So basically that says that the x value of the midpoint, if we add together -2 and 4 and then average that, we average by adding together and dividing by 2, we get 2 divided by 2, which is 1. So this is the x value of the midpoint. You can actually see that over here, halfway between -2 and +4 is +1. The y value, you've got a y value here and a y value here. So if we want to find the vertical halfway point between 3 and 5, well, that should be easy. What's exactly halfway between +3 and +5? 4. Some of these you can do in your head. So if I add 5 plus 3 and divide by 2, this is yet another way to do it if you can't figure it out in your head. 8 divided by 2 is 4. So the midpoint for part A is x value of 1, y value of 4. They wanted to call us that, or have us call that M. Now, here's another example where they give you a couple endpoints. They give you endpoints C and D, so they have an x value here and an x value here. Can you figure out what point x value position would be exactly halfway between -8 and 2? Well, if you can't come up with that in your head, we could average those two together. You get -6 divided by 2, -3. Did anybody come up with -3? And the y value? You have a y value down at -1 and a y value up at +4. What is exactly halfway between -1 and +4 on the y-axis? Well, again, if you can't do that in your head, you can always use the formula of averaging those two y values together. Turns out it's 1.5. You can write it as 1.5 or 1 1/2, either way. So the midpoint for example number 3 The x value would be -3, and the y value is 1.5. Could you have left it at 3/2? Absolutely. You can leave it in fractional form, you can convert it to decimal, or you can write it as a mixed number 1 and 1/2. Alright, now we're going to do a slightly more advanced example. In this example, we're going to try to find an endpoint. This is more of an A-level question, so I'm only going to do one of these examples. You'll notice that I kind of skipped over this one up here because I only want to do one of these A-level examples. So down here, talking about the midpoint, what they did is they gave us the midpoint. This is actually the answer that we were doing all this work for up here. Like, this is our midpoint answer. But in this question, that's not actually the answer. Here they kind of want us to go backwards and figure out, okay, if one endpoint is this, -3.7, and the answer was 5, -6, what's the other endpoint? I'm going to call that x sub 1, y sub 1. Okay? So basically, in order to find the original answer, wouldn't we take this endpoint and this endpoint and do the averaging, right? So we would do x sub 1 plus the other x value, which is -3, and then we divide that by 2, right? And then we would get the x value of the midpoint as our answer. And that x value was 5. And for our y value, we took the endpoint y values and added them together. So we did y sub 1 plus the other y value of the endpoint 7, and we divided them by 2, just like we did right here. And our answer, they already gave us the answer. The y value of the midpoint is -6. So I kind of set up this process, but in doing so, I have an answer and I'm missing one of the original data values. But it still helps us because knowing the process helps us set this up. This is an equation. What I'm going to do right now is I'm going to basically cross multiply. I'm going to think of this as 5/1. X sub 1 plus -3 times 1, if I multiply everything this way, I get x sub 1 plus -3. If I multiply this way, I get 2 times 5, which is 10. And then I have a simpler equation. Again, I multiplied this way and then this way. And all I have to do to figure out the x value of that endpoint that I'm missing is solve this equation. X sub 1 equals 13. For this one, I'm going to write this over 1. I'm going to multiply this way. 1 times anything is just that thing itself. In this case, it's y sub 1 plus 7. If I multiply this way, 2 times -6 is -12. And then if I subtract, I'm going to start subtracting because I want to solve this as an equation. I want to figure out what y sub 1 is. So if I subtract 7 on both sides, y sub 1 equals -19. So while the midpoint answer was already given, and they only gave us one endpoint, finding the other one, we could do this. We could set up 2 equations and then cross multiply and solve the resulting equation to figure out endpoint z. Endpoint z turns out to be an x value of 13 and a y value of -19. Again, that's an A-level question, so if you're really good at algebra and you're good at interpreting the question, then you can go ahead and try that one because that's the more advanced level on the quiz.